So, hello everyone, here Dr. MD Shamim. Welcome to Dr. MDS Academy. In this animation, I am going to show you how in multi-layer cylinder valve heat conduction takes place. In the left side figure, you will find you will be having different layers or different layers. Layer 1, 2, layer 3. Okay. So in these layers, the heat take place in the radial directions as we had seen in the theory. Here below you will find a live one applications where in multi-layer cylinder valve how the heat conduction takes place. So when heat temperature inside the wall of the cylinder is higher, so here T1 is greater than outer temperature, then definitely the heat radiation will take place from inner to outer, and there will occur different resistance R1 for first layer, R2 for different layer, second layer, and R3 for the third one. In the below here, in the below, see Q is equal to given as change in temperature. In the denominator, you will be getting different sum of the resistance. So in animations here, see T inner. What is inner? Inner is the inside temperature. This is our 3D cylinder having three different R1, R2 and R3 layers. This is our R1. See this R1 hollow one here R1, decreasing the R1 value. Okay. Now increasing the R1 value. This is the R1 radius cylinder, and R2 is this one. When you are rising, the diameter radius is in. Similarly R3, okay, when we are changing R4, R4 is the outermost, okay. So you will find the different variations. K1 is what? K1 is the thermal conductivity of the first one, means this one K1. K2 is for this one, and K3 for this layer. Similarly here, what is T inner? T inner is the inside this red one temperature here, inner temperature. T outer is the wall temperature. T naught is equal to 6 degrees Celsius. Currently it is. When you are rising, say I have kept at 51 degrees Celsius, the outer one, and inside one is set at 184 something. Okay. In the below, R1 is the log R2 upon R1, which we had already seen here. See here, R1 is what? R1 is the this one, ln R2 upon R1 divided by 2 pi k in K1 into L for the first layer. Similarly for the R2 and R3. Okay. Now moving to our animation parts here. Okay, as you are decreasing the T inner temperature, see T inner temperature when you are decreasing, see what is happening. There is no effect on the resistance here. However, Q here, Q is what is happening? Q decreasing. See here. Okay. Now when you are rising the T inner temperature, the difference in temperature is going larger and larger. See here, 136 currently. So the Q is rising because Q and T inner has directly proportional. When you are similarly when you are decreasing the T outer temperature, see what is happening? The difference is getting increase and increase. So Q will rise. Okay. Similarly, when you are rising the Q outer temperature value, see what is happening? The Q value is decreasing. Okay, now what is L? L is the total length of the cylinder, this length of the cylinder. So when you are decreasing the L value, decreasing this L value here like this, okay, so what is the relation between Q and L here? Q and L has what is the relation? Directly proportional. So it must increase. So when you are increasing the L value, the Q is increasing. See here, the Q is increasing. See, the value of Q is increasing. See here, when you are increasing, the L is okay. Similarly here, when you are changing the value of R1, see R1 when you are decreasing, what is happening? Okay, the Q value is what is happening with R1 when R1 is decreasing? It is Q is decreasing. Why it is happening? Because Q and RT1 has inversely proportional. When it will decrease, the Q must increase. Okay, when R1 C is it is the radius. Okay, R1 is what is radius. When you are decreasing the radius value, see your radius value when you are decreasing, what is happening with Q is decreasing. Okay, you can check from here also. Okay, similarly R2 variation, see the resistance is given as ln R2 upon R1 2 pi k into L here. See, when you are playing with R1, see the resistance value here. The resistance value is what is happening. See, it is decreasing. Now it is okay. Similarly, you can play with R2 also. Similarly, R3 resistance, R4 like this. Okay. K1 is what? K1 is the thermal conductivity. So when you are decreasing or varying the K1 value, the Q value is when you are decreasing the K1 value, what is happening? Q is decreasing. Why? Because it has directly proportional. As you know that Q is Q is having the Q is having the directly proportional. Q is equal to this Q, K2, Q and K1 like this. Okay. So more is the K2 value, more is the Q you will be getting. More, less is the Q3, lesser will be the Q. Okay. So this was all about the how the conduction takes place in a composite cylinder, which is mainly used in the cables and steam power plant, where the steam or high temperature fluid has to be transported. So thank you all.